Good day, students. We will be your teacher for this virtual lesson. We are teachers
Aldrin.
Azriel, Aljon. We are the teachers A.
Pedro is walking on a straight line, but suddenly walked in a curve when another person was moving towards him.
Juan is walking going to school. He checked his watch and noticed he was getting late. Because of that, his speed became faster and was running, compared to before when he was only walking to catch his class.
Or when Isaac was sitting under a tree and suddenly an apple fell down on his head.
Yes, our topic is acceleration. But how are these scenarios related to acceleration? Well, as you notice, there is one common variable on the three scenarios. It is change. Change in speed, change in direction, and also gravity. These three factors leads to one idea. What is that idea? It is acceleration. So, what is acceleration? So, in this lesson, we will discuss two kinds of acceleration. The acceleration due to velocity and acceleration due to gravity. Acceleration due to velocity is the rate of change of velocity with respect to time. And there are two factors in velocity, which are speed and direction. So it is the change in speed and direction for both in respect to time. Basically, acceleration is the name we give to any process in which velocity changes with respect to time. And velocity has two factors, speed and direction. Meaning, you can only accelerate in two ways. It's either changing your speed, changing your direction, or changing both.
To help you better understand, here is a diagram and we will also give you an example. You're not changing your speed and you're not changing your direction, then you simply cannot be accelerating no matter how fast you are going. For example, you are going on a trip to Japan and you rode a commercial plane. The plane dashes at 1,000 miles per hour in a straight line. Your speed is very, very fast but is constant remaining at 1,000 miles per hour. Are you accelerating? No. However, when you are now in Japan and the plane starts to go down and slow down to the land, that is where acceleration occurs because there is a change in speed and change on its direction. Sir, the plane slowed down. How is that even considered acceleration? Well, we have this thing called deceleration or the negative acceleration. This means that the velocity of an object is decreasing. So yes, I therefore conclude that there is still acceleration even when you are slowing down.
So, sir, what is acceleration due to velocity? So, acceleration due to velocity simply means that it is a change in velocity in which it involves the increase and decrease in speed that is being calculated in velocity all over time. And it is being quantified in meters per second squared.
Sir, how can we differentiate velocity from acceleration? Well, velocity refers to the speed of an object in a given direction, while acceleration implies any change in the velocity of an object with respect to time. While velocity describes how fast and in which direction an object is moving, acceleration, on the other hand, quantifies how quickly an object's velocity is changing.
Since acceleration due to velocity pertains into the velocity in which it pertains into the changes in speed and direction, You can accelerate on your velocity if you change your direction, or you change your speed, or you change the both aspects or the factors that is presented on the board.
Hello again, class. To help you further understand this lesson better, we will present you a problem. A problem specifically for acceleration due to velocity. So, what is the thing that we need before solving the acceleration due to velocity? Yes, it's the formula. So, what is the formula? The formula is acceleration equals by the change of velocity all over time. Sir, how could we get a change in velocity? It is simply by subtracting the final velocity by the initial velocity all over time. So as stated in the problems, let us identify the given. So the given are, what is the final velocity? Yes, it's 25 meters per second. And the initial velocity? Yes, it is 5 meters per second, while the time given is 10 seconds. Now, sir, how can we solve now for the problem? Simple, simply by substituting the formula. So now let us substitute. What is the final velocity? It's 25 meters per second. Subtracted by the initial velocity, which is 5 meters per second, divided by the given time of 10 seconds. So 25 minus 5 is 20, divided by the time, 10. Now I will give you 3 seconds to solve for the answer. 3, 2, 1. Now, do you think we've come up to the same answer? I think so. Because the answer for this is 2 meters per second squared.
Topic for today is acceleration due to gravity. Acceleration due to gravity is a constant value that represents the rate at which an object accelerates towards the Earth's surface under the influence of gravitational force without any other force acting on it. The standard value of gravitational acceleration is 9.8 meters per second, denoted by the g, gravity. This is acceleration is due to the combined effect of gravitational attraction and centrifugal force from Earth's rotation. You may ask, how did we get 9.8 meters per second? This value is derived from the formula G means gravity is equals to G, gravitational constant, times M, the mass of the body of the Earth, and R, the radius, or the distance from the center of the Earth. But bear in mind, the acceleration due to gravity varies depending on the location on Earth's surface. At a different points of Earth's surface, the free fall acceleration ranges from 9.764 to 9.934 meters per second, depending on a little or the altitude, latitude, or longitude. Now you may ask, does all planets have the same acceleration due to gravity value, or 9.8 meters per second, and why? No, because since the mass and radius differ from each planet and celestial body, the acceleration due to gravity will also be different. Why different? Different planets and celestial bodies can vary significant based on their individual masses and radius. So that's how we explain the acceleration due to gravity. Thank you for listening.
The acceleration due to gravity is a fundamental concept in physics, particularly in mechanics and gravitation. It plays a crucial role in understanding the motion of objects under the influence of gravitational force, including the orbits of planets and satellites.
the free fall of the objects, and the behavior of objects in a gravitational field.
So thank you for that, Sir Azriel. And let us now move on to the acceleration due to gravity. So, in solving the acceleration due to gravity, we need the factors in which we involve the mass of the object, the radius, and the given, and the constant gravity, in which it measures the 6.67 times 10 raised to negative 11. And for the mass, it measures the 7.35 times 10 raised to 22 kilograms. And for the radius, 1.74 times 10 raised to 6 meters. And for that, we will arrive on the formula of acceleration due to gravity is equals to constant gravity times the mass all over the radius squared. So let us now solve the given problem. So we need to substitute the 6.67 times 10 raised to negative 11 times 7.35 times 10 raised to 22. After all over 1.74 times 10 raised to 6 squared. So this you will going to solve this through the use of scientific calculator, which will be presented here.
Let us now move on the proponents of acceleration. The discovery of acceleration and its relationship with force has been attributed to various scholars throughout the history. Galileo Galilei in the 16th century discovered that the velocity of a falling object is dependent on its waist. And Sir Isaac Newton in the 17th century formulated the law of universal gravitation, which explained both the fall of bodies on Earth and the motion of heavenly bodies. Newton's discovery of the relationship between force and acceleration became one of the fundamental concepts in modern physics.
In summary, acceleration is the rate of change of velocity with respect to time. The formula for average acceleration is A equals by Vf minus Vi all over t, where A is acceleration, Vf is final velocity, Vi is initial velocity, and t is time. Acceleration can occur when an object's speed changes, either increasing or decreasing, or when its direction of motion changes even if the speed remains constant. Acceleration is distinct from velocity. An object can have a high velocity but low acceleration, or vice versa. Acceleration is measured in units of distance per time squared, such as meters per second squared. There is also the acceleration due to gravity, which includes the concepts of gravitational force and mass.